In problem 21, we're given this table of the years since 1960 and the price of a gallon of milk in those years. And the problem says the prices P of a gallon of milk in a certain part of the country from 1960 to 2000 are shown in the table above. A least squares regression line for the 9 data points is P equals A plus BT. That's a linear equation where T is going to give the number of years since 1960. A is 0.057, B is 0.069, and again T is the number of years since 1960. For the year 2005, what is the value for the price of a gallon of milk as predicted by the regression line? Now, assuming that you understand what all of this means here, the regression line is fairly simple. And we would set it up this way: 0.57 plus 0.069t, where again t is the number of years since 1960. And in the case of 2005, t should be 45 because 2005 is 45 years past 1960. And so all we would do is substitute 45 for t, and we would get 0.57 plus 0.069 times 45, which is 3.675. Rounding to the nearest cent would be 3.68. And so our answer would be D there. All right, now I just want to take, that's pretty straightforward, assuming you knew what was going on. If you didn't know, let's talk about what a least squares regression line is and how to do something like that on the calculator. So first of all, we're going to go into the stat function, and then to edit, and then over to list 1. And I'm going to add all those values in the first column. Okay, so I'm assuming that you can do that, and then we're going to go and add the prices in the second column. And again, I have those all in there, and assuming that you can put them into that list correctly. Okay, so once we have them in there, what we can do is we can make a scatter plot of our data. In order to make a scatter plot, we need to set our x and y axes accurately. So the x-axis is going to go from 0 out to, say, 45 or 50. And the y-axis, we could start at 0, and the maximum value is $3.15, so maybe we could have that go up to 4. To do this, we go to our window, and we set the x-min and x-max to be 0 and 50. The x-scale we'll set to 5 because those will be the tick marks, and that's what we're using now anyway for our data points. The y value should go from 0 to 4, and we can have those go up in 25-cent increments. And so your window should look something like that. The next thing that we're going to do is to go in and set up a stat plot. We turn it on by selecting 1, by clicking on the highlighted on, and we go down to type. That first type is the scatter plot, and our X list is in list 1 and our Y list is in list 2, and so all we need to do here is to go to graph now, and we can see the progression of values. It looks fairly linear, but anyway, we're going to make a least squares line of regression for that. So first I'm going to go back to the main window. I clear that out, and then I'm going to go to Stat again. This time over to Calc, and I'm going to go to the linreg, ax plus b, but I think that this particular time it was given to us as a plus bx, so these are almost exactly the same. So I'm going to select that, and it assumes that your x values are in list 1, your y values are in list 2. Otherwise, we can put in list 1, comma, list 2, and then run the regression. I'm going to take a snapshot of that data and then leave the calculator. And you can see that the A is 0.566, which rounds to 2 decimal places of 0.57, and B, rounded to 3 decimal places, would be 0.069. And I'll continue this in the next video.